Welcome to the Future Tech edition of the Finding Genius podcast. Forget frequently asked questions, forget common sense, common knowledge, or Googling for information. How about advice from a genius in their field instead? 95% of people in any profession are good enough to be qualified and licensed. 5% go above and beyond. They become very good at what they do, but only 0.1% are the geniuses of their profession. Richard has made it his life's mission to interview the geniuses of their fields in areas such as AI, 3D printing, quantum computing, blockchain and Bitcoin, and more. Don't miss out on amazing podcasts with geniuses. Review us on iTunes or wherever you listen, and go to futuretech.findinggeniuspodcast.com and subscribe today.
Hello, this is Richard Jacobs with the Finding Genius podcast, Future Tech Edition. I have Mark Pipher, VP of FacilityConneX. They're working on legislative frameworks and smart building tech that could impact carbon emissions, just in general, but I'll let Mark explain it more. So, Mark, thanks for coming. How are you doing?
Good. How are you, Richard?
Really good. Well, tell me more about your company. What's the premise?
So FacilityConneX has been in business for about 6 years, really looking at really driving energy savings, but more from an equipment optimization. So we look at the way equipment works and offer the correct optimization techniques or parameters to basically make it work better and save energy.
Really better in what context? To reduce emissions from it, or say electricity?
Definitely better from an energy perspective, which always drives your total energy consumption, which is always basically tied to the calculations of carbon emissions. So in the end, it's all about reducing carbon emissions by basically fine tuning your equipment. That's the best way to say it.
So what kind of equipment? Like major industrial type equipment, or is there a niche within there that you're working with?
Yeah, so we focus on mostly the facility-based equipment, things like the HVAC process, the building envelope when it comes to how it consumes chilled water, steam, all those aspects that really drive utility type carbon footprints from utilities that are being consumed by that building. And by looking at that entire process and drilling into the equipment on how the equipment is behaving, we find faults and fault conditions that can basically be resolved and drive that cost down. It's very simple from that perspective.
So when you say drive the cost down, like what are any case studies and examples of what you've done?
Yeah. So we've done everything from standard commercial buildings, residential buildings, all the way through healthcare and industrial facilities. Across the board. And typically we save in the HVAC energy reduction, we save close to about 10 to 15%. When you bring the more complicated piece of equipment or critical type equipment like chillers and boilers, those numbers can actually raise to close to 20%, which is equivalent reduction in your carbon footprint.
That's great. How do you do that? Like, I don't know if it's proprietary, but what are some of the efficiencies you see, and how do you improve them?
Yeah, that's a great question, Rich. I think the best way to think about it is, most people can't monitor all the equipment, just by looking at a screen, right? You can't, in some of these buildings, like a building that's, 250,000 square feet or more, you're talking, thousands of pieces of equipment. And so how does a facility engineer, monitor that type of equipment? And typically the building actually just absorbs into 1 meter. So you can't really understand what pieces of equipment are actually causing that higher consumption. And what FacilityConneX does is, we use analytic techniques that use the data that comes from every piece of equipment in the building. So all 1,000 equipment, and we're watching that piece of equipment with these analytics for things like very simple, sometimes very simple things like simultaneous heating and cooling. Basically that's a simple, I can't tell you a building I have not found simultaneous heating and cooling happening, where the same unit is heating and something else is cooling at the same time, the same air, right? And so when you do that, you're wasting one side or the other, depending upon what's happening on the outside air.
With airflow, though, in particular, like how do you avoid recycling it so that it's not stale and full of, pathogens and things like that? Like, how do you find that optimal mix, or are you not recycling, or just taking the heat component, or what?
So all typical commercial buildings tend to recycle air, like you're describing. Not all air is recycled. You always bring air from the outside as well. It's a balancing act, and we're monitoring that balancing act based on temperature, humidity, outside conditions, all that stuff, to basically offer the right optimized approach for that flow of air. Now, in specialized areas like operating rooms and labs type conditions, mostly that is driven by outside air. You tend to never really recycle exhaust air from those specialized areas because you don't want to, bring any type of bacteria or chemicals back into the system.
When you recycle, though, what kind of filtration is there, or is it just a recycled fraction?
It's the filtration is what the system provides, mostly on the discharge, where the filtration. I'm talking more about maintaining temperature using the mixed air type approach.
Is the main benefit just recouping the heat energy that would otherwise be wasted, or buildings say, hey, we want to be healthier, we want to up our percent of non-recycled air or fresh air?
Oh yeah, no. So there's definitely standards where you actually have to keep a certain level of outside air and replenish that air. So that's very clear. But there is a balance, right? So what I was talking about when I meant the simultaneous heating and cooling is it's really that the unit shouldn't be heating when it's the air needed to be cooled, even though you were doing both at the same time, and that happens a lot. It happens when there's multiple pieces of equipment, processing that air. Now all air gets processed by one piece of equipment. It goes downstream into a bunch of VAVs and terminal devices that have to basically be adjusted, and they have to work in conjunction. Some of those units have heating coils in them, and if they're heating the air after the air conditioner is cooling it, you're going to force it to cool more at the air handling unit level. And that's what simultaneous heating and cooling is. And when you're watching you have thousands of terminal devices or VAV boxes, and you only have one or two air handling units, you have to basically condition, you have to be watching both sides of the stick, so to speak.
What about changing the order of the cascade? If you have a facility with a couple of really high heat processes where it exhausts very, very hot air, can you change the cascade so that hot air, will be used to benefit other processes that need hot air but not quite as hot, and cascaded temperature-wise down through the system differently than it currently is set up?
Well, typically that's done in the control equipment, right? And so when we look at it, we're not really controlling the equipment. What we're doing is monitoring the equipment and seeing if that type of condition or that condition can be improved upon. Does that make sense?
Yeah, I just wonder if when the facilities are designed, is that taken into account? Like, we run 10 processes and these are the hottest, and therefore that heated air is really useful for other processes, so it's not wasted.
Yeah, absolutely. There's obviously heat recovery, heat wheels. There's a lot of techniques, and usually that's built in the design. But as buildings, get old over time, equipment gets old over time, and people make changes without understanding how it behaves across the entire building and the entire envelope of the building. And so what systems like FacilityConneX do is really try to monitor and maintain that design, that baseline that was originally put in place.
So, usually I would think people would say, there's an AI system that, monitors everything and keeps it in the right ranges. Is that at all what you do? Or is it that, why is there a need for what you do? Is it because the systems, when they're installed, they're not smart enough in the first place? Or why is it needed?
That's correct. Yeah. So what happens today, in most cases, systems were built based on some baseline that was done during the original construction of the building. Occupancies change, buildings change, walls change, zones change, and things just change along the way over the years. These systems don't get adjusted, these control systems that do that. And so when we come in, we watch that control system, its behavior, and then we basically offer the right set of changes that need to occur in order to make that behave much more better or clearer or optimized, I would say, is the best way to say it. And that never gets done unless someone does what's called the retro commissioning process. And retro commissioning does a great job at solving those issues day one. It's a manual process. But even after that happens, you're not watching the building anymore again. So you have to, having a system with AI on board, you're basically watching and always improving your system over time, which means you're driving that carbon footprint down over a period, over the years and years, and you're ensuring it never comes back up.
So what causes, do facilities reach out to you or you reach out to them? And if they reach out to you, what prompts them to do it?
What prompts them to do it is, we have, there's several ways, right? One is the system, the user can get on, our clients get on our system and they look at the screens and it gives them different variables to look at. One is cost of energy, second is preventive maintenance, and then third is comfort, right? It basically looks at all three of those perspectives, gives them a prioritization based on those perspectives, and they go after solving some of those issues. The second way is we have built-in alerts and notifications where someone can be alerted to take a look at a particular situation that might be going on. And then the third way is what we call the experience. We have actual experts in, carbon and energy and the equipment itself, and they get on the phone once a month with our customers and take them through a few of these problems where they can basically save energy and drive that cost down. So we basically have all three of those ways as part of our service that we do, and it's built right into our subscription.
Well, what's at stake for a large enough facility? You said 10-15%. What is that maybe in dollars and cents, throughout a year of savings?
Well, I think, in a building about 250,000 square feet, you're probably talking, could be about $3 million electrical bill. So you can see that you're looking at about 10%, through the low end of that spectrum, 10% is what they could save off that $3 million electrical bill. That's
awesome. And how long do the savings go on for typically? Multiple years?
Yeah, so we have customers that have been on our system for 5 years straight and have renewed. We have a 95% renewal rate, and it's really the onus is on us to basically show that continuous return on investment, right? Because we get on the phone every month with them to show them why we're basically saving them money. So they see that savings year over year. They don't, basically the return on investment for our system is about 6 to 8 months.
Do they incorporate you into the planning? Do they call you and say, hey, Mark, we're planning an expansion of the facility, or we're going to change this or bring in this new equipment. We want to get you in the loop so that you can keep us optimized?
Yeah, and that's actually, you bring up a great point. I mean, getting in the early part of it, a lot of times we go into existing buildings that have been around 50 years, right? So, but getting into the early part of a building when there's doing an expansion or new construction is key because you start to see the baselining effects. And the other nice thing about that is you're in the warranty period, right? So any design or optimization issues that come up during the findings, they're basically for free, right? Because you go back to the construction company to resolve it before you sign off on that new construction. So the warranty period's in place. We've done that with a bunch of customers where they've gotten a bunch of changes and optimized, came in before they basically opened up the new area, the new facility. They basically fixed all these problems day one. So, and then it becomes more monitoring, make sure someone doesn't make a change at that point.
Are there any new optimizations or ways that you could push the envelope and make it even more efficient?
Yes. So a lot of times, those things require maybe change outs is the typical word that's used. Certain piece of equipment, might be basically not capable of doing some of these optimizations. And so, or adding some new sensor technology might actually help it be able to control these pieces of equipment better. So we offer a lot of those things during these experience calls, discussing what the best approach is. Sometimes air handling units that are 15 to 20 years old should be replaced, right? You get a higher efficiency based on that. And usually the new units come with a lot more capabilities from a sensor technology that gives you the ability to monitor it even better. So a lot of those things come up during these calls as we find findings along the way.
When new equipment comes, is it good enough where your services aren't needed, or is it manufacturing still lagging the best efficiency it could be?
I would say that, a lot of times the manufacturer isn't the issue, or the manufacturing unit's the issue. They do, obviously, these units become more efficient as they come out over time, and they've done great work in the facility space. What I would say is that, people have to program these units so that they work in conjunction with all the other pieces of equipment that's in the building. And that control and that logic tends to start off fairly well, doesn't take into all the aspects of the design of the building. But more importantly, things change. Other pieces of equipment downstream might get affected by those changes, or a human being might have made a change and he didn't realize the effect. A great example of it, someone might actually adjust the chilled water that's coming into a building by raising its temperature up, thinking they're saving money at the chilled water. But in essence, that effect basically changed the way the air handling units basically were pushing cool air, and the supply fans basically ran hotter. They ran more because they had to basically still maintain the temperature into the areas that they were targeted to. And just by making a couple of degree change actually caused a higher energy consumption than what they thought about when they originally made the change at the chill level. Those type of things happen all the time. And what happens in those cases is our analytics find those issues and report them right away in real time. And by adjusting that degree back down, you bring your supply fans down and you save energy and obviously drive your carbon footprint down as well.
That's cool. Okay. Any things that the old buildings had or old equipment has that you like? Do they get things right that modern manufacturers or modern buildings don't get right?
I think you have to take each case as themselves, because I do think that it's not just one thing fits all. A lot of different buildings have different unique conditions. Different areas require different controls and different designs. So I think it just depends on, the type of building you're in. But like I said earlier, we find issues year after year. We find issues early on, typically a lot of issues. A lot of them are very low-hanging fruit. You don't have to replace the unit. You just basically make a quick control change. And, there's a lot of places in the country where utility companies incentivize people to drive these carbon footprints down and drive the energy down based on, wanting to basically save energy, because they're incentivized to do that. And so there's a lot of times you can basically get money from the utility company in order to basically make these changes and fixes.
Really? The utility company will pay? Why?
The utility company also has governments basically driving carbon footprint, so they only can generate as much energy, to a certain level up to their carbon footprint as well. And so they incentivize companies to reduce energy based on government programs to drive, so they can use the energy other places, because they only can produce so much, right? So they're trying to play that balance. That's why they charge you more during peak hours, because they want to basically get you to reduce your consumption. It's kind of a funny model, huh?
Well, I guess it makes the utility company look better if it delivers a certain amount of power each year, and that power is used more efficiently. So probably that's
right.
why there's that incentive.
Yep.
Even though it's not really in their control, unfortunately, they have the thankless job of having to keep an eye on that.
Exactly. Yeah. Yep. Exactly.
So anything, you've been in this for a while. I mean, I don't know if you've seen it all, but anything really new that's coming or interesting, or just something that really surprises you about what you do or what you see?
Well, I think I get surprised all the time from whenever we connect to a new building. So, some of the things that I have seen, over the years is simple approaches to some of these things like just simple schedules, monitoring, when things should be on, when things should be off, or when they're reduced. Kind of is really something that you can easily do with a system like this. The more complicated things where I see the technology going is in places like these places where you have lots more complicated air balancing and air conditioning type issues. And more importantly, they're usually incentivized by the fact that you have certain comfort parameters or environmental health and safety issues. Those ones I'm very keen on these days because I think the AI type analytics actually provide a better way of seeing these things. More importantly, they're actually high. I mean, you could save 25 to 30% in some of these areas just by managing your air change rates around those areas as well. So I see a lot more benefits, but because they're complex areas, it just makes sense for an artificial intelligence or analytics to do that work for you.
Yeah, have you worked with buildings that have that use solar or use wind or geothermal? And if so, do you have any observations on those? How do those units work versus traditional energy source ones?
Yeah, I mean, there's a lot. There's been a lot of incentives out there for putting solar and wind type technology into play. And, I don't see as much of that because we don't necessarily monitor those things, but we do bring in the energy information and the metering because it complements it. But, you basically still, you still want to run your building as efficient as possible, even though you bring in the sustainability type energies like solar and wind in there. But, all I see there is it definitely reduces the amount of energy you take off the grid, so it's a huge savings overall. It still doesn't make your equipment efficient.
Well, is that equipment any more or any less efficient than traditional equipment? Is there any observation there?
No, I don't have any observation there. Like I said, we don't necessarily monitor wind and solar. We tend to monitor what the energy that it's producing, how it's consumed. So.
Okay, I gotcha. Is there, I mean, is electricity? Is water, or are there different types of energy that some of these units draw, like 240 volts versus 120? When you get into industrial, I guess, the currents and the volts are different. So, are there certain kinds of power that are harder to optimize or better?
Not that I'm aware of. Most of these, especially in industrial, is DC. So, but I'm not really familiar or haven't really seen patterns like that, to be honest.
Okay, I'm just wondering.
Yep.
So, what's the minimum criteria that a facility needs to have in order to make it worthwhile to work with you?
So, typically, we always go into buildings that have a building management system. They have that control type system. We tend to, when it comes to big plants and stuff like that, we go right down to the control units themselves. So I would say the minimum that we look for is make sure you have some type of control type equipment and networking. We are a cloud-based service, so we tend to push that data to the cloud, then let the analytics do the talking. But having said that, that's probably the minimum. We've done buildings as small as 50,000 square feet. We typically, on average, see a better return in buildings around 100 to 150,000 at a minimum square feet. Anything bigger than that, you're going to get quick returns above that.
Okay, what's the best way for listeners to get in touch with you if they need this help when they work at a facility that could use the help?
Yep. So we're on the web, so they can contact us at sales@FacilityConneX.com. They can look at some of the use cases. We do have a blog on there as well, so they can see some of the findings of the week and see if any of those things are challenges that they face every day. And just contact us through sales@FacilityConneX.com, and one of our salespeople will contact you directly.
That's great. Well, Mark, thank you for coming. I appreciate it.
No, thank you.
You've been listening to the Future Tech edition of the Finding Genius podcast. This podcast is information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed. Review us on iTunes or wherever you listen, and subscribe today by going to futuretech.findinggeniuspodcast.com.